test for equality of two proportion. Given two sample of size n1 and n2 from two population with the sample proportion p1 and p2, we would like to test whether the proportion p1 and p2 of the two populations are equal. Here H0 null hypothesis p1 equal to p2. The alternative hypothesis p1 is not equal to p2. Two-tailed test. On the assumption of H0 is true, the sampling distribution of p1 minus p2 is approximately normal with mean 0. And standard error of p1 minus p2, that is square root of pq by n1 plus n2. So here the test for statistics is equal to p1 minus p2 divided by square root of pq into 1 by n1 plus 1 by n2, where p is equal to n1 p1 plus n2 p2 divided by n1 plus n2. Q is equal to 1 minus p. And inferences, if modulus of z is less than 1.96, H0 is accepted at a 5% level of significance. Modulus of z is greater than 1.6, H0 is rejected at a 5% level of significance. And modulus of z is less than 2.58, H0 is accepted at 1% level of significance. Modulus of z is greater than 2.58, H0 is rejected at 1% level of significance. On the same lines, we can give the procedure for one-tailed test. Example, a machine produced 20 defective articles in a batch of 400. After overhauling, it produced 10 defective in a batch. Has the machine improved? That is our question. The solution: let P1 and P2 be the proportion of defective articles produced by the machine before and after overhauling. So N1 equal to 400, N2 equal to 300. So P1 equal to 20 divided by 400, P2 equal to 10 divided by 300. Okay, here batch of 300. So best estimate of P is N1 P1 plus N2 P2 by N1 plus N2. That is equal to 400 into 20 by 400 plus 300 into 10 by 300 whole divided by 400 plus 300. Use a calculator. We get 3 by 70. So Q is equal to 1 minus 3 by 70. That is 67 by 70. So H naught P1 equal to P2. The alternative hypothesis P1 is not equal to P2. But here P1 and P2 is some small difference. So we can use one type P1 or P2 is less than, P1 is greater than P2. One tile test. The test is equal to P1 minus P2 divided by square root of PQ into 1 by N1 plus 1 by N2. That is equal to 0.050 minus 0.033 divided by square root of 3 by 70, 67 by 70 into 1 by 400 plus 1 by 300. So use calculator. 0.017 by 0.015, that value is 1.13. The table value at 5% level of significance, one tile is 1.645. Conclusion: H naught is accepted at 5% level of significance since Z is less than 1.645. Therefore, the machine has not improved due to overoiling. One example: random sample of 400 men and 600 women were asked whether they would like to have a flyover near their residence. $200 men and 325 men were in the favor of it. Test equality of proportion of men and women the proposal. Solution: let P1 and P2 be the proportion favorable to have flyover among men and women population respectively. So N1 400, N2 600, P1 200 by 400, P2 325 by 600. So P is equal to N1 P1 plus N2 P2 by N1 plus N2, that is equal to 400 into 200 by 400 plus 600 into 325 by 600, the whole divided by 400 plus 600. So use calculator. 525 by 1000, that value is 0.525. 0.525. So Q is equal to 1 minus P, that is 0.475. Now H naught is P1 equal to P2, P1 not equal to P2, alternative hypothesis. So the test statistics is Z equal to P1 minus P2 divided by square root of PQ into 1 by N1 plus 1 by N2. That is equal to 0.5 minus 0.542 by square root of 0.525 into 0.475 into 1 by 400 plus 1 by 600. So use calculator. This value is minus 0.042 by 0.032. That value is 1.31, a negative value. So modulus of Z is equal to 1.31. The table value at 5% level is 5% is 1.96. So conclusion: H0 is accepted at 5% level of significance. Since Z is less than 1.96, therefore men and women populations equally favor of the proposal.